Good morning, all of you. And inverse is a transform. First method, long division method. Okay. Second one is partial fractional method. Third one is residual method. Okay. So we'll start with long division method. Okay. First problem. Using long division method. Using long division method. Determine the inverse is a transform. Determine the inverse is a transform of x of z equal to 1 plus 2 z power minus 1 divided by 1 minus 2 z power minus 1 plus z power minus 2. Okay, so from this x of z we have to find out x of n. And the given condition, first one, if x of n is causal signal. Second condition, x of n is non-causal signal. Okay, long division method or other name for this method is power series method. Both are same. X of z given, we have to find out x of n. Two conditions. How to write x of n in causal format and how to find x of n in non-causal format. Okay. Suppose x of z given in the form of z power 1, z power 2, z cube and all. You convert the given expression into a constant 1 plus z power minus 1 plus z power minus 2 and so on. Denominator also same thing. Okay, so it's better convert the given x of z to this particular format. Okay, 1 plus z power minus series format, you have to convert it by multiplying numerator denominator with the appropriate value. Right. So first method, if how x of n to be causal. What is causal signal? The signal available only in the positive value of n. So in this example, it is directly given numerator 1, constant first, and then z power minus 1. Okay, so let's take as it is. If not, also you have to arrange the equation in this order for causal signal. And denominator 1 minus 2 z power minus 1 plus z power minus 2. Okay. Now we have to select the value such that this term must be cancelled. The 1 must be cancelled. So here 1 is there. So if we multiply with 1, 1 multiplied with 1. 1 multiplied with minus 2 z power minus 1 plus z power minus 2, right? 1 multiplied with this entire value, you will get this. Now subtract this, 1 minus 1, 0. Plus minus of minus 2, you will get 4 z power minus 1. This is minus z power minus 2. Okay. Next, select your value such that this term must be cancelled. 4 z power minus 1. So here 1 is there. So 4 z power minus 1. If you multiply 4 z power minus 1 with this, you will get 4 z power minus 1 minus 8 z power minus 2 plus 4 z power minus 3. Now subtract these two, cancel again. So minus of minus 8. So you will get 7 z power minus 2 minus 4 z power minus q. Now select a factor such that to cancel this 7 z power minus 2. So 1 is there. So 1 7 z power minus 2, 7 z power minus 2. Okay. Next 14 z power minus 2 plus 7 z power minus 4. Now do the subtraction. This term will be cancelled. Okay. So 10 z power minus 3 minus 7 z power minus 4. So repeat the same procedure at least 5 to 6 value. Now 10 z power minus 3. So 1 multiplied with 10 z power minus 3. Okay. 10 z power minus 3 minus 20 z power minus 4 plus 10 z power minus 4. Subtract, cancel it. So what is the result now? 13, right? 13 z power minus 4 minus 10 z power minus 5. Repeat the same procedure now. Plus 13 z power minus 4 and so on. So minimum 5 to 6 values you have to calculate. Okay. For long division method or power series method, given x of z, you must write in the form of 1 plus z power minus series. Okay. 1 plus z power minus 1 minus 1. Denominator also. For x of n to be a causal signal, then as it is 1 plus 2 z power minus 1, 1 minus 2 z power minus 1 minus 2. As it is, you have to take it and proceed. Okay. So this will be continuing. This will be continuing. Now your answer is x of n equal to 1, x of n equal to 1, comma 4, comma 7, comma 10, comma 13, comma and so on. Because if we expand x of z formula, x of n z power minus n varies from minus infinite to 0. Sorry, minus infinite to infinite. If we expand this, substitute n equal to 0, x of 0 z power 0, 1. X of 1 is z power minus 1, x of 2 is z power minus 2, x of 3 is z power minus 3, x of 4 is z power minus 4. Okay, so coefficient of z power minus 1 is your x of 1. So your x of n result is constant, that is x of 0. 1, comma 4, comma 7, comma 10, comma 13, comma and so on. This is your inverse is a transform result. X of n causal. See, x of n, we got the result in the causal signal only. The signal start from n equal to 0. Okay. So this method called as long division method. Finding inverse is a transform using long division method. Second case is given. If x of n to be non-causal, then how to derive? X of n to be non-causal signal. Sorry, power problem. Okay. So x of n to be non-causal. Then how to solve this problem? So what is given x of z? X of z equal to 1 plus 2z power minus 1 divided by 1 minus 2z power minus 1 plus z power minus 2. Okay. Even if the problem is not in this particular format, you have to convert the given x of z to this particular format. A constant z power minus 1 minus 2 series. So for causal signal, we take as it is. For non-causal signal, particularly x of n to be a non-causal signal, this constant should come at last. Say for example, numerator 2z power minus 1 first, and then a constant. You have to write in the reverse order. Z power minus series, the highest term should come first. Z power minus 2 minus 2 z power minus 1 plus 1. Now you have to do the division process. Two z power minus 1 plus 1. Please remember, for to write x of n in non-causal format, you have to rearrange the given equation. Let z power minus highest term first, constant at last. Okay. 2z power minus 1 plus 1. Okay. Now select the value. So if we multiply that particular value with z power minus 2, I should get 2z power minus 1. Say for example, I am taking 2z. 2z multiplied with z power minus 2. I will get 2z power minus 1. So 2z multiplied with minus 2z inverse, I will get minus 4. 2z plus 1 plus 2z. Subtract. This term will be cancelled. So 1 minus of minus 4. 5, 0 minus 2z, 2z. Next, select a value such that the 5 should be cancelled. So I'll select 5z square. 5z square multiplied with z power minus 2 will get 5. So plus 5z square minus 2z inverse, get minus 10z plus 5z square. Subtract, it cancel. Now result 8z minus 5z square. Next value, if you select 8z cube, so 8z cube multiplied with z power minus 2, you will get 8z minus 16z square plus 8z cube. Subtract minus 5 minus of minus 16. So we'll get plus 11z square minus 8z cube. So continue the same process, at least minimum 6 coefficient. So now we should select 11z power 4, so that this 11z square will be cancelled, right? 11 z power 4, z power minus 2. So you will get 11z square. 11z square minus 22z cube plus 11z power 4. Do the subtraction. This term will be cancelled. Then you will get 14z cube minus 11 z power. Okay, and so on. So I suggest minimum 6 value you have to find out. So next factor we should select 14 z power 5 and so on. Okay. Now if we compare this particular equation with Z transform formula, x of z equal to x of n z power minus n, n varies from minus infinite to infinite. This general formula. Compare this result with the standard formula. There is no constant here, right? So x, if you substitute n equal to 0, x of 0 is z power 0, x of 0 constant. Z term is there, meaning n equal to minus 1. X of minus 1 is z power minus into minus plus. Okay, so this is x of minus 1. Z square coefficient x of minus 2. Z cube coefficient x of minus 3, x of minus 4 and so on. So now you can write your result. 0 is not there. 0 is not there. In this example, starting from x of minus 1 only. So 2, 5, 8, 11, 14 and so on. Anyway, we should indicate 0 position. Just add 1 0 and indicate the arrow mark. So that this is x of minus 1 and so on. Okay. This is a non-causal signal, right? Non-causal signal. So do you understand this power series problem? Simple cases. X of n to be causal, meaning a constant is z power minus 1, is z power minus 2 and so on. Non-causal meaning z power minus series, highest term first. You have to rearrange this equation in this order. Then if you compare the quotient with the standard formula, you will get the coefficient for x of minus 1, minus 2, minus 3 and so on. Okay. This is first method of inverse Z transform. Example 2, x of z given z plus 1 divided by z square minus 3z plus 2. Find the inverse Z transform x of n for causal and non-causal. Now how to solve this? There is some other method is there, but I don't want to confuse you. You always convert the given x of z to this particular format. That is a constant and then z power minus 1, z power minus 2 and so on. Numerator. Denominator also a constant, and follow this procedure. First problem procedure. Okay. So even though x of z given z or z square format, you convert the given x of z to the first problem format. What is the maximum term z square is there? So multiply z power minus 2 both the numerator denominator. Okay, so z power minus 2 is z. So you'll get z power minus 1 plus z power minus 2. Denominator z square z power minus 2. Z power 0 will get 1. Minus 3 z power minus 1 plus 2 z power minus 2. Okay. So you convert to this particular format. Now your x of z has a constant z power minus 1, z power minus 2 and so on. Numerator constant is not there. Let it be z power minus 1, z power minus 2 and so on. Now follow the first problem format. X of n to be causal as it is. X of n to be non-causal. You have to rearrange this equation. That is higher order term first. 2 z power minus 2 minus 3 z power minus 1 plus 1. Numerator is z power minus 2 and then z power minus 1. See how we arranged this. For non-causal signal, how we arranged? Constant at last. Okay. Z power minus 2 minus 2 z inverse and then constant. So you may ask the question, so is it possible to solve directly with this? Yes, it is possible, but you'll get confused. So I don't want to teach that other method. Follow this procedure only. So in the question paper, they will mention whether you should follow the partial fractional method or power series method or long division method. They will mention. Okay. Second type of inverse is a transform. It is familiar for us because we solve many problem in Fourier transform, DTFT, Laplace transform. Partial fractional method. Example. Laplace transform, I taught you 3 different cases. Okay. Follow that procedure. Simple pole. Suppose pole repeated 2 times. Suppose poles are in the form of ax square plus bx plus c format. Then how to do the partial fraction? 3 method I taught in the Laplace transform. You follow the same procedure here also. X of z equal to 1 by 4 z power minus 1 Okay. So second method called as partial fractional method. Okay. Example 1. X of z equal to 1 by 4 z power minus 1 divided by 1 minus 1 by 2 z power minus 1, 1 minus 1 by 4 z power minus 1. Find the inverse z transform for the region of convergence modulus z greater than 2. Okay, like Laplace transform, they will mention the region of convergence. If they are not mentioned, you write the result for the causal signal. Okay. So what are the formula to be remembered to solve this problem? A power n u of n, z transform result, z divided by z minus a, modulus of s greater than a, minus a power n u of minus n minus 1, z transform, z divided by z minus a, same result, but ROC is modulus z less than e. These two are important formula. So apart from this, n a power n minus 1 u of n. This is another formula. Result is z divided by z minus a whole square. Okay. Next, n into n minus 1 a power n minus 2 u of n divided by 2 factorial. You won't get this formula, but maximum order 2 possible up to this formula, up to this possible. Your z divided by z minus a whole cube. Okay. Most of the cases we will be using the first two. Region of convergence greater than a pole, less than a pole. How to write your result? So this is very important. Okay. So this is the problem. First convert the given problem into z term. Because z divided by z minus a, I am going to use this formula only. So x of z x of z equal to 1 by 4 z power minus 1 divided by 1 minus 1 by 2 z power minus 1. 1 minus 1 by 4 z power minus 1. So multiply z square on both numerator denominator. So you will get 1 by 4 z. In the z square, I am taking one z for the first term, another z for the second term. So I will get z minus 1 by 2. Z minus 1 by 4. Okay. So always for the partial fractional method, you have to convert the given expression to this particular format. A long division, what I told you, you convert all the z term in the form of z power minus series. Okay. In partial fractional method, it's better to bring the x of z in this format first. If directly x of z given in this format, no need to worry. Okay. So we have formula a power n u of n x z transform result is z divided by z minus e. For that purpose, like DTFT, while finding inverse DTFT, what I told you, we always keep 1 e power j omega left side of the denominator. Here also I am keeping 1 z here. So that at last I can multiply this z right side. I'll get the formula z divided by z minus a format. So x of z by z equal to 1 by 4. Suppose z term is not there here. So what to do? You multiply z both numerator denominator and then take that particular numerator z to the left side of the denominator. Okay. So 1 by 4 z minus 1 by 2. Do the partial fraction. A divided by z minus 1 by 2. Two poles are there, both are simple poles. Order is 1 only. If order is 2, you know how to solve it. That we discussed in Laplace transform. Okay. Now that time you have to use this formula. Z divided by z minus a square. Then your result is n into a power n minus 1 into e of n. So a divided by z minus 1 by 2 plus b divided by z minus 1 by 4. Solve it. 1 by 4 equal to a times of z minus 1 by 4 plus b times of z minus 1 by 2. Substitute z value and find out ab. Substitute z equal to 1 by 2, you will get b. Substitute z equal to 1 by, so z equal to 1 by 4, b value you will get. Z equal to 1 by 2, then a value you will get it. Okay. So a and b value. A divided by z minus 1 by 2. Okay. You will get 1. Okay. So we'll get a equal to 1, b equal to minus 1. Now substitute in the main equation x of z by z. A value 1 divided by z minus 1 by 2. B value minus 1 divided by z minus 1 by 4. Okay. Now you multiply this z right side. X of z equal to z divided by z minus 1 by 2 minus z divided by z minus 1 by 4. You got it now why we are keeping the z left side? Finally, we have to multiply that z right side so that we will get the formula z divided by z minus a format. Okay. Z divided by z minus a. Result is a power n e of n. For modulus of z greater than or outside of outermost pole. If inside of innermost pole, minus a power n u of minus n minus 1. Between two poles, we have to analyze and write the result. Okay. In Laplace transform, we solve the problem, same format. Now in this example, I'll tell you all possible values of ROC. For all possible ROC. Writing result is very important in partial fraction for all possible region of convergence. You will expect the question like this only. Or they will mention z is greater than 1 by 2 or z is less than 1 by 4 or between 1 by 4 to 1 by 2. Okay. So if you solve this particular problem, again cross multiply and something, that is in the initial format, right? 1 by 4 z divided by z minus 1 by 2 z minus 1 by 4. So how many poles are there? There are two poles. z equal to 1 by 2, z equal to 1 by 4. There are two poles. Right? 1 by 4 and 1 by 2. Real part of z, imaginary part of z. So there are two poles. So if we assume the ROC is outside of outermost circle. The ROC is outside of outermost circle. ROC Z is greater than 1 by 2. That is outside of outermost circle. Then your signal is a causal signal. So x of n result is Z divided by Z minus A. Inverse is a transform A power n U of n. So 1 by 2 power n U of n. 1 by 2 power n U of n. Plus second term minus, okay, Z divided by Z minus 1 by 4. Z divided by Z minus 1 by 4. 1 by 4 power n U of n. Okay. So this is your inverse is a transform result when we assume the region of convergence is outside of the outermost pole. The case 1. Case 1. Next, if we assume the ROC is inside of innermost pole. Assume ROC is inside of innermost pole. So there are two poles are there in this transfer function. 1 by 4, 1 by 2. Draw a circle with a radius of 1 by 4. Draw a circle with a radius of 1 by 2. Suppose assume the ROC is like this. Modulus is less than 1 by 4. Okay. So already we discussed in the beginning of the Z transform. Causal signal is a transform always outside of outermost circle. If more than one causal mixer. For non-causal signal, the ROC lies inside of innermost pole. Okay. Now your result is, you should write the formula Z divided by Z minus A inverse is a transform minus A power n U of minus n minus 1 for non-causal signal. Please don't forget this formula. Causal signal Z divided by Z minus A, the result is A power n U of n. Non-causal signal, you have to write minus A power n U of minus n minus 1. So in this example, minus 1 by 2 power n U of minus n minus 1. Minus, already the one minus is there, so that will be cancelled. So 1 by 4 power n U of minus n minus 1. This is the result for inverse is a transform. If we consider the region of convergence, that is modulus Z less than 1 by 4. ROC is inside of innermost circle. Okay. So two possible cases we discussed. Final one, suppose ROC between these two poles. Third possible cases. You read the question carefully. whether the condition given or not. Let us assume 1 by 4. Okay. Third case is, if region of convergence, that is modulus of Z, between two circles, between two poles. Okay. Then how to write your result? 1 by 4 less than Z 1 by 2. Between two circles. So for this, how to write your result? Is Z greater than 1 by 4, right? Is Z greater than 1 by 4? So where is 1 by 4 term is there? This is 1 by 4 term. Correct? So this result you have to write in causal format. A power n u of n format. So minus, already there minus 1 by 4 power n e of n. Second cases. Is that less than 1 by 2? Is that less than 1 by 2? Inside the circle. Where is 1 by 2 term is there? First term. For this term, you have to write non-causal format. Minus a power n u of minus n minus 1 format. So minus 1 by 2 power n u of minus 1 minus 1. So this is your result. For ROC between two circles. Okay. Same concept like Laplace transform. While finding the inverse Z transform of the given signal, they will always specify the ROC condition in the problem. If the ROC condition not specified, you write the answer in the causal format, a power n u of n result only. Sometimes you may expect the question like, find the inverse Z transform for all possible region of convergence. What do you mean by all possible region of convergence? Particularly in this example, only two poles, right? So you assume outside of outermost pole, case 1. You result in the causal format. Second case, assume inside of innermost pole. Then your entire result in non-causal format. Next, assume ROC between two poles. Only 3 possible cases are available. Between two poles, for that case you have to write carefully, because ROC less than 1 by 2 and ROC greater than 1 by 4. So greater than 1 by 4 term you should write in the causal formula. Less than 1 by 2 circle, that particular term you must write the answer in non-causal format. Okay. Similarly, many problems are there in partial fractional method. You have to use this method only. A power n u of n Z transform Z divided by Z minus a. ROC greater than a. Minus a power n u of minus n minus 1 Z transform. Result is Z divided by Z minus a. But Z is, these two is the fundamental formula. Using these two formula only we can write inverse Z transform result. This one outside a circle. ROC. inside a circle with radius A, outside the circle with radius A. Individual signal. So any doubt in the partial fractional method? Keep always one z, x of z by z, while doing the partial fraction. So that finally we will multiply that z right side. So that z divided by z minus a format we will get. So long division method or power series method and partial fractional method for all possible values of region of convergence. In yesterday class we solved difference equation, how to find transfer function, and how to check stability of the system and all. Okay. So basic problems in Z transform, properties, and few problems using properties. Discrete time LT system described by the difference equation, relationship between DTFT Z transform, and power series method, partial fractional method. So this is sufficient, but one more method is available, residue method, that we will discuss in the tomorrow class. Then we will complete all the syllabus. So any doubt, please.